was gonna do that with Gadget. I did also a training with them.
Yeah, I got a little hard drive.
Yeah, like insane, and it was like 4,000. It was like a
As far as I can tell, the first one that we raised, the Dell Lab, size, file, it weighed, you know, a big fraction of the size. And was inherently dangerous. You know, and you can imagine lots of them staying $500. Yeah, yeah.
My phone.
I mean, my phone is like, you do realize that's more powerful than like the original. And
I'm gonna have to sit next to you.
Yeah. I mean, so this is 128 gigabytes.
Yep.
Like exponentially more.
25.
Yeah.
Speaking of, I'm also running my data on that many devices.
Yeah,
That's
so-
insane.
Because all the monitors on so much. Like one picture on your
Yeah,
iPhone.
like, that's what I'm trying to explain.
I bought the sheet of
That's perfect.
It didn't have enough.
It weighs nothing.
No,
Just need- I don't think so. Yeah, it'll work.
And I was like.
Don't freak out.
And I was like, you don't understand.
It's all that out of lead.
It doesn't work.
Yeah.
Can't process it.
I just did.
So I-
It's sort of.
Well, I eventually found something
That could do
that
it.
could do it.
Get the wood.
As for being.
You couldn't really handle that.
It's
That's crazy.
definitely
You would have to
gonna
have a 5 different computer.
I think we said that.
Oh, that's insane.
Well, one of the sales for this software.
I think part of the.
There's this option, highlight.
Getting
Nobody knows about Xyrite. Xyrite was the word processing.
Is that it's got relative to the point there, it's got a lot of.
Yeah.
The first one,
That area's gotta go somewhere.
Yeah.
yeah.
The one I originally thought of making
Oh,
more like.
it kind of depends on you.
And for the prototype, I made it only an inch
The most amazing thing was
and that
to
seemed to be
realize
bigger.
what the memory was.
And
And
it
memory
made
really
me
was.
something where instead of having it be completely open on
And
product,
it
it
was
was actually a contained product.
In a mercury delay tube. That it had to be.
Right, yeah.
And that way pressure would build up a little
Because
bit.
it would explode and shower the room with mercury.
Oh my gosh.
The computers were
The purpose
inherently
of the
dangerous.
paper so you can use white.
Yeah.
And then,
That's
you know,
pretty cool.
militarizing it.
That was the big, yeah.
That looks good.
Yeah, it's one of those things.
Yeah.
You know,
Yeah.
to make it work.
And not explode and kill everybody.
Yeah, the first, the earliest computer,
Here's your.
because it was so fast.
It's closed all
I
the way.
mean, the one they, you go to German signals with
Right.
For years, yeah.
Yeah.
I saw that.
Somebody said it sounded
Right,
like.
that, yeah, that's what
Yeah.
I'm thinking, like,
And it just
almost
got a bunch of spinning.
maybe a quarter of an inch. Just to.
Yeah, can you imagine like putting that together?
If I can make it lighter and wider, that'll work better, like compressing it more and making it spread out more.
And the math of that.
Or if that's gonna start working again. I looked at,
And they had really
it seemed to work,
sophisticated.
like the top of a.
Right, so in other words, all the
They were like,
factors
no,
and
just
then
You wanna shoot?
show the size of one flag, it's a garage.
Have you ever looked at that? They literally like.
Yeah, that's so I was thinking of one I had the TV on the side. And I didn't look like.
Yeah, it's a long way.
If I can get.
Well, that
It
was,
doesn't
that's
have
why
to
they were
spin
so
fast,
fast.
it just has to spin. Right, if I can get the flow, then maybe I'll. So
That was my
things like that, maybe that'll.
Yeah, at that point.
If we open into, we'll be able to hold it. I mean, we have done all the past.
I don't know. Do what?
I don't think that's-
Yeah, like, I don't know.
Okay.
Part of it is thinking about
They've got it all sussed down.
More time to
Fix the-
Yeah.
I remember the first computer I've ever used was my father's. I was going through a school and I held up mouse and played because I didn't know that with those extra display. So I held up the screen. Killed the entire screen. It was bad. They were
That was bad.
They almost killed me because that was in like $2,000 favorite computer. Yeah. My school was lucky, we had the like colorful maps, those were the revolution. We had like a colorful map and it had the sword. Yep. And I did that all. They had a row of all different colors.
The damn side view mirror popped out of it.
It was one of the original
Like, only just a little stick. How we gonna get it on the side?
Yeah. 5 years. That was one year. You were lucky to have those. My era of like consciousness really began. That was like. So that was when I actually started learning.
Whipped out her BlackBerry and said, would you take our picture, please?
And you can
And
actually.
I was like,
It's
you
not
have to line it up and hit it right silent.
Well, it's swapped. It does a lot of this.
You didn't think technology like that might just.
Because what was I going to like, not once you get like.
You remember?
You remember like.
Yeah,
So
I got
excited
one
to
of those.
have the file that you could use. This thing's awesome.
Thank you, person. What year model is that? What year is that model?
Okay, good afternoon. First of all, thanks for being here. I know it's beautiful outside, but it's gonna be beautiful inside too. Okay, thanks for being here. And come on, have a seat, have a seat. Yeah, thank you. Okay, so today I'm very happy that we have two outstanding alumni, Chris Owens and Smith Newnam. They graduated from our industrial design program in 2008. active like yesterday, and they've been doing very well. They got a lot of cool projects. Actually, we bought a lot of computers for our new space, and then realized they design, for their team design the computers. And many of our students actually really like the computers. So I think they have a lot to share about their journey, their project. So I will just let you guys start. And the other, the talk, we have some Q&A. Okay, let's welcome Chris and Steve.
Thank you. We are senior designers at a consultancy called Propulsion, based out of Austin, Texas. I'm working in Austin. Smith is working remotely here in Chapel Hill. We do work for a wide range of clients, from big corporate companies like Dell and Lenovo and FC Johnson, and small startups and inventors who have an idea for a Kickstarter and need help getting a working prototype or a brand off the ground. A little bit about ourselves. I'm Chris Owens. I had a lot of internships when I was in school, which I think were super valuable and something to really take advantage of in the program. I worked at Velasquez, which was an offset printing company, big industrial factory type environment. NC State Delta, which is a multimedia production house here to help faculty have multimedia resources for their classes. Trig, doing industrial design projects. Midwest Baco doing packaging design. Philips Color Kinetics doing LED lighting for buildings and large scale applications. And then Dell internship doing enterprise computers. And I've also done some kitchen appliances for Black & Decker, Redmond, and Houston. So that's just an idea of the range of experiences that I've had.
Yeah, no, it's clearly a lot less ambitious. Yeah, so I graduated in 2008, the same year as Chris, and just went straight into doing freelance, which I don't recommend, but it does eventually lead me back to here. And Chris started working with Design Edge, and what year was that?
I don't know, probably 2010.
Yeah, 2010, and eventually got me into the fold as well, so here we are.
Yeah, so we've been with Propulsion. I've been there for nearly 12 years, and Smith's been there around 7 or 8 years. And so, like I said, Propulsion is based in Austin, Texas. We're a pretty small team of 6 people right now, 6 designers and engineers. We have a couple full-time mechanical engineers as well. And then please check us out at propulsiondesign.com if you want to see any more of our work. What we want to talk about this evening is just a brief overview over some projects that cover the range of experiences that we see at a consultancy. So from working with startup inventor people to working with large corporate clients, and how those projects differ from a workflow standpoint and the types of problems we're solving, and how our relationship with those clients is different, and how we might plug in with an existing team or be the leaders of a capability that the client doesn't have at all. This project called Zent was for a toothbrush. Super exciting project, right? This was an individual who was fascinated with oral health care, and he wanted to address the problem of people brushing too hard, which can cause receding gums. And the treatment is extremely painful and expensive surgery to like graft new skin on your gums or something. Didn't even want to look into it. So he wanted a toothbrush that would break if you brush too hard, but then when you let up, it would work again. And he had some rough garage prototypes using magnets and was thinking about springs and all of this stuff. And he came to us saying, like, how can we make this work? How can we make this a functional product? And here's some of the branding we did to illustrate why it's good and bad to not brush too hard. Few illustrations. And so we started brainstorming and came up with like a snap bracelet. Like, you know, it's rigid until you hit it too hard and then it deforms and loses all of its rigidity. But how do you make that spring back into place? So we used a tape measure and put them face to face so that
it would break and snap back in both directions. And then through several rounds of prototyping of changing the curvature of that arc and the width of that, and then the shape of the cavity that it plugs into, we could tune the force that it took to break that snap bracelet, basically. And we ended up with a fairly nice looking product, I think, that also had some manufacturing challenges because we have a spring steel strip inside of a flexible joint tool shop. And so we had to work with the tooling factory to figure out an insert that would keep the material from flowing into the spring and all of the stuff that they were scared to do. And we just had to convince them. We figured out how to do it. And so that's that. We also helped with the branding, website. Again, it was one guy working out of his home. So we built a lot of that company for him. Yeah, I think it's a good example too of a project that's kind of like deceptively complicated. You know, it seems like a really simple concept, but you know, the two phases of the project were developing a feasible approach mechanically, but then also translating that to manufacturing. That I think is really where the bulk of the work was extremely valuable in making sure that we had a little cap here that could come out, and then a part of the steel could then form this cavity inside here. So I think that's where really the project shines, but it's a story that no one ever sees, which is makes it fun. Yeah. So sometimes we get asked to work with big corporations and their design team, and they come with often in-house designers, which are very talented and are looking for some fresh ideas. And so that's where we will come in to give them some inspiration or paths to explore.
And that relationship is much more of a collaboration. It really feels like you're joining that design team that's already there and working. And it's almost like getting hired by that company for a month.
Right, so it contrasts very sharply with the previous project where the guy just had an idea and no concept of how to implement it. Whereas in these scenarios, you know, we're working with designers who know the ins and outs to a great degree of the particular field that they're working in. So for this project, it was kind of fun because we had to approach it from a more traditional design approach, in that we did a lot of models, a lot of sketching, and then here you can see we translated those models for the mouse into 3D with a 3D scanner, and then that we use as an underlay to help us with the CAD, and then Chris worked on the keyboard, which involved a lot of rim shape and machining, and then you know, user testing of those models. And so this mouse has a pretty fun application of cork material, which was a material challenge that the manufacturer took on. But yeah, I think the surfacing of this mouse was a fun SolidWorks challenge. Looks like the keyboard.
Yeah, the main study here, these are both ergonomic products. So how do you untwist and unbind your joints while you're using the keyboard and mouse? And so here you're using tenting, which is taking the center of the keyboard, bringing it up, and also splaying, which is angling that bottom line apart. And that's all an effort to get your arm to be in line between the keypad that you're typing on and your shoulder, with a right angle at your elbow. And because you're wider than a keyboard, you have to splay those angles apart to get that relationship to work out. So the rim shape, those were quick CNC block models that we would do several different explorations in CAD and then cut them out of that rim shape foam so that we could sit in front of them and validate those designs. And then once we found those angles that worked nicely, there was a lot of very careful surfacing to get those surface transitions to happen in a very small amount of space so that the keyboard stays compact, but also in a gradual way so that visually there weren't any jarring transitions or like highlights or anything like that. So then we
we also carry that core material to the palm rest, which was that important touch point that you're always interacting with on the wrist.
Yeah, so the fun thing about working on projects like this, with Lenovo, Dell, is that, you're working with designers, so, you can kind of speak the same language within your team, and, they sort of act as guides to the design process. And we'll come up with a lot of different variations and explorations, but, it's really their vision that helps, guide, the ultimate design, that we help implement. So then, this is also a family of accessories for Lenovo, wherein the primary challenge was to develop a family language that very strongly communicated across the range of products. And so all that is also had to fit within the Lenovo design aesthetic, which is very clean, minimal surfacing, geometric forms. And this is the range of products we developed. A few of them aren't quite announced yet, so those are blurred out. Yeah, I think it turned out pretty well.
Talking about blurring out, so it's okay to take pictures out if you like to, but to a certain point of time, expectation is that shows on confidential information, and we will stop before we start taking pictures. No pictures, yeah.
Yeah, so this mouse part of the project was another process where we did a lot of foam models and a hands-on process.
What is that material on the bottom here?
That's a plastic with a speckled paint application. And then the earphones, for these, there had to be a lot of ergonomics consideration. So actually, we scanned an ear into 3D to try to make sure that all the design aesthetics requirements and aesthetic goals that we're trying to fit into the product actually made sense within the context of a human ear. So that's the primary challenge there. So back to the other end of the spectrum, this is a dog toy that it was a guy who came to us in another sort of inventor level, and he wanted to develop basically like a Kong dog toy that would release the treats over a given period of time. And so his problem was that treat releasing dog toys, the dog will either figure out how to do it very rapidly and get all the treats out, or they'll never figure it out and are just frustrated and chew the thing to death. So what he wanted to do was have a timer that released treats on a delay. And so this is a case where he came to us with a concept that was not marketable, because essentially the product would have been a couple $100 because he wanted to put Bluetooth and electronics and all kinds of crazy stuff, which also would have been destroyed. So this is like an illustration of how it works. There's an interior component which rotates and has a large hole, which then aligns with progressively larger holes as the time goes by. So you get larger and larger treats coming out of the device. So our kind of greatest contribution, I think, was in steering him towards the direction that we could manufacture for a reasonable MSRP, and that was actually to include a little kitchen oven timer in the base. And so it's a very inexpensive mass manufactured component, which is off the shelf, which we could incorporate, and you just twist the top here, the top dial, and that rotates the interior component. And the fun thing about designing for dogs is that they always tell you if they like it or not.
Give it to a pet octopus.
You figure it out.
Did the ticking sound make them crazy?
Yeah, they do really like the ticking sound,
Yeah.
actually. So yeah, they kind of get worked up into a frenzy, and then the really smart smart dogs would know that you'd have to wait. And actually, some of them were able to turn the dial if they really got the call. We also did the branding, which is kind of fun because it's a lightning bolt as the dog's ear.
And a good pun as well.
Right. And so this is another example where we went from concept all the way to market as far as our contributions. So packaging, retail, and even trade show.
And Kickstarter campaign, right? Did you do that again? Yeah, so this was a Kickstarter product. We did all the assets, all the videos and images, other renderings, and copy, I believe.
Yeah,
For the Kickstarter campaign.
Yeah, we built out the entire Kickstarter page.
Which, that's, Kickstarter campaigns are a good chunk of work for Kong Spectrum.
Right. It's not free money.
And Kong has ended up buying this company, so this has now been a success for the original inventor as well. He's been able to exit from the success with the Kong. But I think they even hired him.
Yeah.
Yeah. But a lot of fun. This one's pretty brief. This was a on-ear noise canceling headphone set that we worked with Lenovo on creating the overall visual style and some of the CMF explorations. Just trying to get extremely clean forms that mechanically work nicely with the types of joints and extensions we needed to fit the head. And then our concept is on the left, and then the product to market is on the right. Really, we were proud of our felt material and the renderings.
So this is a product that I felt particularly happy with because it felt like it kind of did some good. A lot of stuff we work on is just for fun and just pushing the new thing. But this is a band that lights up and vibrates when someone sends a message to it. And the core concept is that people who are in the hospital or recovering from injury or illness need to know that people are thinking about them, but they need to receive that communication in a way that they don't feel obligated to reciprocate, because that can actually create some stress on them because they feel like they have to give back as well. So it's called Caring Band because it's a band that they can wear and know that people are caring about them. So this was a sort of mid-level client. It had some venture capital raised, and so we did the mechanical engineering, which is really simple, and then from original concept all the way to market, and developed a short run of these are urethane models, which was in use in a pilot program at St. Jude's. And so the project to me was significant because it felt like it was really making a difference in the kids' lives who felt the impact and gave a lot of positive feedback about the program.
So we wanted to take a quick moment to ask no photos and video again, like we already mentioned. Dell doesn't usually let us show process when we talk about our participation with their teams. And so they, because this is a personal one-on-one design presentation, they have given us permission to show some process that we've never been